When people think about the power behind the RMS Titanic, they usually imagine its massive steam engines, the giant pistons moving up and down, driving the ship forward. Please subscribe. But beneath that well-known system was another piece of technology, quieter, less visible, and often overlooked. It was the turbine system, a hidden component that played a crucial role in how Titanic moved through the ocean. To understand the turbine, we first need to look at how steam was used on the ship. Titanic generated enormous amounts of steam by burning coal in its boiler rooms. This steam was then directed into the main engines, where it powered large pistons through a process known as triple expansion. By the time the steam passed through these engines, much of its energy had already been used, but not all of it. Instead of letting this remaining energy go to waste, Titanic used it in a different way. This is where the turbine came in. The leftover steam was directed into a low-pressure steam turbine, designed to capture the final portion of energy that the main engines could not fully utilize. Unlike piston engines, which rely on back-and-forth motion, a turbine works through continuous rotation. Steam flows over a series of carefully shaped blades, causing them to spin. This spinning motion is smooth and efficient, converting the energy of the steam into rotational force without the heavy mechanical movements seen in piston systems. On Titanic, this turbine was connected to the ship's center propeller. While the two outer propellers were driven by the main engines, the central propeller was powered by the turbine. This setup created a hybrid system combining traditional piston engines with more advanced turbine technology. This design offered several advantages. First, it improved overall efficiency. By using steam that would otherwise be wasted, the turbine allowed the ship to extract more energy from the same amount of fuel. Second, it provided smoother operation. The continuous rotation of the turbine reduced vibration and added stability to the propulsion system. However, the turbine system also had its own limitations. It depended entirely on the output of the main engines. If the flow of steam from the triple expansion engines was reduced or interrupted, the turbine would receive less energy. This meant that the turbine could not operate independently. It was part of a larger, interconnected system. The placement of the turbine within the ship reflected its role. It was located further back, aligned with the central propeller shaft. While not as large or visually dramatic as the main engines, it was still a significant piece of machinery, requiring careful design and precise operation. For the crew working in these areas, the turbine added another layer of complexity. It had to be monitored and maintained alongside the main engines, ensuring that steam flow and pressure were properly managed. This required coordination and understanding of how each part of the system interacted. From an engineering perspective, the inclusion of a turbine represented a step forward. It showed how designers were beginning to combine different technologies to improve performance. The Titanic was not just relying on established methods. It was also incorporating newer ideas, pushing the boundaries of what ships could do at the time. Looking back, the turbine system of the RMS Titanic is a reminder that innovation often happens in layers. Not every advancement is visible or widely recognized, but each plays a role in shaping the whole. It also highlights how complex systems depend on balance. The turbine did not replace the main engines, it complemented them. Together, they formed a system that was more efficient and capable than either could be alone. More than a century later, the idea of combining different propulsion technologies is common in engineering. Hybrid systems are used in many forms of transportation, reflecting the same principle that was applied on Titanic, making the most of available energy. In the end, the hidden turbine system of the RMS Titanic was more than just an extra component. It was a quiet innovation, a way to go further with what already existed, a system working behind the scenes. And while it may not be the most famous part of Titanic's story, it remains an important piece of how the ship moved, driven not just by power, but by efficiency, design, and forward thinking.